Hello. We present you a video guide in Digimuseum. In the video lesson we will introduce you to photogrammetry and the reality capture program, with which we will digitize tourist sites. We will pay attention to scan material with a drone and camera and how to make 3D models from the captured material. At the beginning we will start with the science of photogrammetry and how it is used in the digitization of objects. The architect Albrecht Meydenbauer was the first to use this expression in 1867. Photogrammetry is a scientific discipline that deals with determining the shape, location, size and characteristics of objects in their photographs. The name comes from the three Greek words, photos, light, gramma, drawn, and metrio, measure, or measurement on photography. The objects of study can be huge in size or microscopic, located on the Earth's surface, under it, under or on the water, in space or on the laboratory table. The purpose of measurements can be to determine the location of objects in a flat plane, or in three-dimensional space. Measurements are most often made on the basis of photographic pictures, one or more, taken from different shooting stations, stereo images, located on the Earth's surface, ground, in the air, on airplanes, or in outer space. Photogrammetry is used in architecture, archaeology, astronomy, geography, geology, urban planning, shipbuilding, but mostly in geodesy and cartography, to create and update topographic maps and plans for various purposes. That is why photogrammetry is often called phototopography or photogeodesy. The photogrammetry obtained from the photographs is divided into metric and interpretive. The task of metric photogrammetry is to determine the location, dimensions and geometric shapes of objects in their photographs, and the interpretive, to recognize objects, to clarify their content and meaning. Depending on the applied methods for restoration of the spatial information about the objects, the photogrammetry is divided into analog, analytical and digital. In analog photogrammetry, the solution of basic photogrammetric problems is performed using the methods of analog modeling. In analytical photogrammetry, the reconstruction of the spatial model is done by computational means. The practical processing of the current stage of development of photogrammetry is done on a computer. Analog and analytical photogrammetry use analog images, most often obtained by photography, to perform measurements in photographs. The third direction of modern photogrammetry is digital photogrammetry. In it, the image is represented as a two-dimensional matrix of numbers, which is called a raster or digital image. Measurement and visualization processes are performed on this matrix. According to the methods of capturing objects located on the Earth's surface, we distinguish between terrestrial photogrammetry and aerial photogrammetry. In the upcoming video we will get acquainted with the interface of specialized photogrammetry software, namely reality capture. The software is designed to create georeference 3D models of various objects, such as buildings, maps, monuments, interiors and more. In other words, in short, a geographical coordinate system of all photos is provided for the purpose of visualization and analysis of information. Let's show you. We open reality capture. This is the first window that opens to us, namely, Help menu. It is written in great detail and understandable. As you can see, it is not small, and here you can go very deep into the functions of the program itself, because we will pay attention only to the main functions. We will give you a foundation on which to build your skills. This is the first button with the software logo. As a basic one, it has functions like most programs. By clicking on it, we can create a new project, open an existing session, save a project we are currently working on, as well as save a project under a specific name. Below are the export button, then the option to export project reports, as well as the share button. On the right side of the panel we have quick access to the latest work. With the exit button we exit the program. The next feature we will pay attention to is this bar. These are different types of visualizations of work windows. You can choose the one that is most convenient for you. These are the three main buttons that combine all the functions of the program. We are currently seeing the workflow toolbar. Let's quickly explain the functions of one of the tools. It is important to note that when you specify a button, a small box appears with information about what function the tool performs, which is quite useful. With the Map Wizard button, scanned material can be processed with a drone. The photos that are taken contain metadata about the field, such as distance, angle, altitude, which data can be read by reality capture and used to more accurately model the object. With real-time assistance, you can add an additional scanning device. From the next two buttons we can insert the scanned material into the software. From inputs, we select specific or single files, while from folder, we specify a folder with organized material. In the next panel we start with the video sequence. With this feature, you can use video for scanned material. With laser scan you insert laser scanned material. With component you insert reality capture components. With ground control you determine the position of the model, etc. You can find out more about the other functions in this panel in the Help menu. The Process panel has the main processing functions. If we press the Start button directly, the program will automatically start building a model with the scanned material. In Align Images we arrange the photos in control points. With Calculate Model you can view the model in different quality during processing. From the Simplify tool you can simplify the model to make it lighter. You have the texture of the object as well as the colors. The Output panel is clearly clear. From here you export the finished model. You can share it or make a video with the object, as well as a photo. The last panel is for setting up the program itself. Again, options for work windows, general reality capture settings, panels and the Help menu itself. On the Alignment button we have more detailed functions of the organization of the material, as well as to add criteria and options for 3D modeling. In the Mesh model, we also have more processing tools. We often use these features, but we will show you how they work in making the models themselves. These are the most basic functions and buttons of reality capture. In the following lessons we will make 3D models from the material we scan. Hello! In today's video we will get acquainted with the basics of drone flying. We will talk about the devices, the technical specifications, the flight safety, the terminology. We will also pay attention to the atmospheric conditions under which it is good to fly and under what conditions it is not desirable to fly. But before that, let's get acquainted with the main components of our system. This is our folded drone. We open the shoulders with the fins. The drone's camera is gyroscopic, absolutely balanced during the flight so that we have a stable frame and image during the flight. The sensors detect obstacles in front of the drone, depending on the settings you have set for it. There are also sensors from the bottom of the drone to prevent it from hitting the roof of a house or tree. This is a USB input. On the other side is an input for a micro SD card, which records video and photos. This is the battery, and with the help of these two buttons you insert and remove the battery accordingly. It is important to know that when the batteries are placed on the charger, they are charged one after the other. By pressing the button on the battery, we check how much charge is in it. For longer battery life, it is important to keep them half full so that you can use their full capacity. With this drone, according to the manufacturer's parameters, one battery can be flown for 20 to 25 minutes, but we never allow ourselves to fly that long, because the battery must have a charge to return the drone to the landing point. On the mobile application you have information on how much charge is left on the battery. Also, the charge of the batteries depends on the weather conditions. If you fly in sub-zero temperatures, the charge of the batteries drops faster. The same is true in strong winds. This is the drone's remote. These two clips are rubberized so that the mobile device can be firmly gripped. Let us introduce you to the main buttons with which we control the drone. This is the button with which we activate the remote control. This button with the letter H is very important. This is a home button, with which you can return the drone back to the place from which it took off. With this button you take photos. And this is the button with which you activate video recording. From here I move the camera in vertical and horizontal position. And, from this we adjust the light sensitivity of the camera. Smartphone, usually USB to USB-C in our case. This is the input for charging the battery for the remote itself. We will now show you how to activate all components. Switching on the remote control is done by pressing the button once and then again with a hold. The drone is activated in the same way. Press the button once and immediately the second time with a hold. After activating the remote control on the display, we receive information during the flight. Kilometers per hour, drone flight speed, engine speed, wind speed, flight altitude, distance between the drone and the remote control. Our advice is not to lose visual connection with the drone. Now we will include the mobile device that serves as a video monitor, that is, to see what we are shooting. And here is a very detailed information about the connection between all devices. The gray icon here shows us that we have no connection with a GPS signal, i.e. the drone is not tied to a GPS signal and cannot be positioned. In general, it is not good not to be positioned, because you lose the ability to return with the home button. This map shows you the position of the drone, but we do not currently have a connection to the GPS signal. Here we have data about the settings of the camera, ISO 400, our tent is 160 white balance is 3800 kelvins. It also shows that we do not have an SD card. There are many more personal settings, but as time goes on and you learn about the devices, you can adjust them to your liking. The devices are switched off in the following order. First we turn off the drone, press the button once, then immediately a second time with hold. The display shows that he is trying to connect to the drone, but there is no way because it is turned off and there is no connection. The remote is turned off in the same way, one time fast and the second time with hold. It shows a shutdown. The device is turned off. Now that we know the basic components, it's time to make the first flight. To start the engines, we push the two joysticks diagonally inwards at the same time. We do it. And the drone is already on fire. Pushing the left joystick forward, the drone will take off. Let's demonstrate. You can see that without pressing anything on the remote, the drone is in the air and even our commands. If we want to land the drone, we do it with the same left joystick, but we push it down. We take off up, we land down. Pushing the left joystick inward only turns the drone's engines off. This is takeoff and landing. We will now show you the other features of these two joysticks. Pushing the right joystick to the right, the drone moves to the right. Pushing it to the left, the drone moves to the left. Pushing it forward, the drone will move forward. If we pull it back, the drone moves backwards. With the left joystick we can rotate the drone around its axis, we rotate it counterclockwise to the left. Respectively by pushing to the right, it will rotate on its axis and clockwise. We lift the drone up and make a circle around the object we have chosen to photograph. An extremely important thing that we must mention is the ban on flights in certain areas or no-fly zone. All drone operators must comply. The provisions established by the government and regulatory agencies, as well as by the International Civil Aviation Organization. For security reasons, there are flight restrictions that allow users to use the product legally and safely. Flight restrictions affect altitude, distance and no-fly zones. A message about such a zone appears on the mobile application when all devices are started. Drone, controller, phone or tablet. You can also check the no-fly zones on the internet. Once we have determined whether the area in which we are allowed to fly, we should consider a few other very important things for flight safety. Namely, make sure you see the drone at all times. Do not choose a place with people, animals or objects such as tree branches or power lines, as well as transparent objects, glass or water surface. Avoid obstacles when the drone flies backwards. Do not fly near airports, highways, railways, train stations, city centers or other busy areas. Keep the drone away from animals. Fly outdoors. Do not fly in bad weather, wind speeds higher than 10 meters, in snowfall, in rainy or foggy weather. Tall or metal structures could cause a compass or GPS error. Avoid places with strong electromagnetic fields, such as base stations and radio towers, to reduce the risk of radio interference. The time for which the drone and the battery will work depends on various factors such as air density and temperature. Be careful when flying at an altitude of more than 6,000 meters above sea level, because the time during which the drone and battery will work may be less. Battery capacity is significantly reduced when the drone flies at low temperatures. It is not recommended to use the battery at extremely low temperatures or below -10 degrees. Now we will pay attention to the symbols and information that appears on the screen of the mobile application. Map with GPS positions of the drone and the point of takeoff. The next parameter is the distance of the drone from the remote control. Here it shows us the flight altitude. This is the horizontal speed of the drone. That's the vertical speed of the drone. This symbol indicates that the sensors below the drone are off. Here we have information about the parameters of the video. Drone battery charge information. The picture quality of the mobile device. The signal strength between the drone and the remote control. Symbol that indicates whether the front drone sensors are activated. GPS signal strength. This field currently shows us that the drone is in flight and is positioned by GPS. When you have a no-fly zone, no-fly zone will appear in the same field on a red background. Warnings and information about your flight are constantly displayed in this part of the screen. These are the warning lines that show us how far the obstacles in front of the drone are. On the right are the video startup settings as well as the video settings. On the left you have the home button, automatic landing and drone control via the mobile app. These are the basic instructions for operating a drone. In this lesson we do not go deep into the subject, but with more practice in flying, everyone can improve their knowledge and experience.